NASA's James Webb Space Telescope is already getting ready for its next trick. Up until Christmas 2021, the most famous telescope is the Hubble telescope. On the 25th of December 2021, the U.S. National Aeronautics and Space Administration, NASA, led the development of another telescope in collaboration with the European Space Agency, ESA, and the Canadian Space Agency, CSA, launched a new telescope into space. The new telescope is known as James Webb Space Telescope. Its mission is to succeed the Hubble Space Telescope as NASA's flagship mission in astrophysics. The telescope has been in space and doing what it does best. What could be its next trick? Do you know about NASA's James Webb Space Telescope? Why will NASA even launch another telescope when there is the Hubble telescope? Welcome to your favorite channel, Unlimited SpaceX. Don't forget to subscribe and hit the notification bell for more exciting videos about SpaceX projects and Elon Musk's many controversies. The James Webb Space Telescope, JWST, was launched on the 25th of December 2021 by the collaboration of NASA, CSA, and ESA. The telescope was launched on a European Space Agency Ariane 5 rocket from Kourou in French Guiana. The telescope has been in space for more than a month now, and its mission has been planned to last for 10 years. The Space Telescope got its name after James E. Webb, who was the administrator of NASA from 1961 to 1968 during the Mercury, Gemini, and much of the Apollo programs. It's been discovered that the telescope is designed to observe some of the oldest and most distant objects and events in the universe, which include the first stars and the formation of the first galaxies, and to provide a detailed atmospheric characterization of potentially habitable exoplanets. Compared to the powerful Hubble telescope, James Webb Space Telescope is more sophisticated. It has improved infrared resolution and sensitivity over Hubble. It can view objects up to 100 times fainter than the faintest detectable by Hubble. James Webb Space Telescope is equipped with the optical telescope element as its primary mirror. The optical telescope element consists of 18 hexagonal mirror segments made of gold-plated beryllium, which combine to create a 6.5-meter diameter mirror. This excellent improvement gives the Webb telescope a light-collecting area of about 5.6 times as large as the Hubble telescope. JWST can observe in a lower frequency range, from long wavelength visible light through mid-infrared, and this allows the telescope to observe high redshift objects that are too old, faint, and distant for Hubble. One important thing about the James Webb Space Telescope is that it must be extremely cold, below 50 Kelvin, negative 223 degrees Celsius, negative 370 Fahrenheit, to observe faint signals in the infrared without any interference from sources of warmth. It's been over 40 days for the James Webb Space Telescope in space, but its chief scientist says the mission is well on track to uncover the universe soon. About the current condition of the spacecraft, a Nobel laureate and astrophysicist who also works at NASA's Goddard Space Flight Center in Greenbelt, Maryland, John Mather, said, "The telescope is cold. The instruments are cooling." The Nobel laureate announced this during a live-streamed Explore Mars event in the 3rd of February. Like we said earlier, the telescope needs to be very cold for its infrared instruments to pick up subtleties in galaxies, exoplanets, and other objects it's examining. The NASA astrophysicist said that the individual photons, particles of light, are starting to register in the telescope's detectors. He added that the telescope is yet to capture any definite image, but it will soon. James Webb Space Telescope has been discovered to be around the second Lagrange point, which is about 1 million miles away from our planet. According to scientists' calculations and theory, this particular region of space balances out several gravitational forces that'll allow the new powerful lens to orbit a point in space with a minimum of fuel. This region is on the side of Earth that's not facing the sun. Webb telescope can capture terrific pictures from this location, and its sun shield will also protect it from the heat of the sun, the Earth, and the moon to sustain the freezing temperatures the telescope needs. In the next 5 months and beyond, John Mather said that the telescope will begin an ambitious science program covering all aspects of astrophysics, but it must pass a rigorous commissioning period first. Currently, the telescope has been trying to align the 18 hexagonal elements of its primary mirror, the optical telescope element. For the time being, they're working as 18 separate telescopes, but it'll soon need to act as a single mirror looking at the deep universe. First, we have to find the images that all of those 18 different hexagons are making, then figure out which one is which, and then start sending commands to the little motors that move the viewers around to get them in the right place, Mather explained. Then surely we get them lined up so they do a nice sharp image with a near-infrared camera. Then we have to check that the other 3 instruments are also in focus. The process hasn't been initiated, as one of the instruments, the mid-infrared instrument, isn't even turned on yet. The mid-infrared instrument should be on by late March to early April, as it should be operational 4 months after the December 25th launch. Other instruments would be operational before that period, as they're bound to be ready in late February or early March. Then we're ready to start announcing our first results around the summer solstice next year, John Mather said. You should know that the way we see space is about to experience a defining change. This is a new lens, and it's more powerful than the Hubble telescope. JWST will produce different images compared to that of the Hubble telescope that we're familiar with. The images will be influenced due to the infrared on Webb, unlike that of the Hubble Space Telescope, which uses different infrared wavelengths, along with visible light. When talking about the power of visibility that the Webb Space Telescope will give, Mather said, "We can see into and through the dust clouds using infrared because the infrared will go around the grains instead of bouncing off. You can boldly claim that the vision of this telescope will go farther into dust clouds where exoplanets are forming, or look at the hearts of dust-filled galaxies. The images will be different, as we'll be seeing more characteristics of pre-existing images captured by the Hubble telescope, but they'll be beautiful." There are also indications that James Webb Space Telescope will look into solar system objects like Mars or Jupiter's moon Europa. The telescope actually has 4 goals. 1. To study galaxy formation and evolution. 2. Study planetary systems and the origins of life. 3. To search for light from the first stars and galaxies that formed in the universe after the Big Bang. And lastly, 4. To understand star formation and planet formation. It'll also succeed the Hubble Space Telescope and the Spitzer Space Telescope due to its infrared astronomy. JWST is bound to surpass these telescopes by being able to see many more and much older stars and galaxies. According to John Mather, who's been managing the development of the project since 2005, the Webb telescope will also shed light on Earth-sized planets orbiting M-dwarf stars, which may be habitable depending on the radiation environment. He said that by probing for life in distant areas of the universe, Webb will not be able to give definitive answers, but can give us some pointers. "We don't expect to see oxygen with this observatory, it's too hard," he said of looking at Earth-sized planets for signs of life. "We're not looking at the correct wavelength to be able to do it, but we do expect to be seeing the presence of water vapor in little planets' atmospheres." While answering a question, John Mather said that the James Webb Space Telescope may also be able to assist with dating stars and globular clusters. This effort will help us with understanding stellar ages and the evolution of the universe at large. Examples of other forthcoming investigations he pointed to included looking at young solar systems in nebulas or gas clouds, and using supernovas to assess the expansion rate of the universe. The telescope may also be used to gather information on the dimming light of star KIC 8462852, which was discovered in 2015 and has some abnormal light curve properties. Seems the telescope isn't leaving space anytime soon. Thank you for watching, and hopefully we'll see you at our next video.